Very warm welcome, dear students, to this playlist on theory of computation or automata theory or theory of computer science. There are different names for this particular course. Okay. So without wasting much time, let me just start off with the introduction of this course and the very first topic, that is introduction to automata theory. So what exactly automata theory is, we'll learn about that in detail in this particular course. Okay. And for those who are new to the channel, my name is Sridhar Iyer and I'm going to be your instructor for this particular course. So let's start this journey. The very first thing that we will be discussing about is what exactly is theory of computation science. Okay, so let me start this. First of all, what happens is you should know what exactly is automation. Now, automation is nothing but there is some sort of a machine. There is a machine, something like this, and you are passing certain inputs to that machine. The machine will apply its own logic or apply its own instructions to that particular set of inputs, and it will generate some sort of an output. Well, theory of computation or automata theory is all about this. You have to create machines, certain machines, which will take the inputs. Based upon certain logic, they will take a particular decision and they will throw out the output. Basically, in theory of computation or automata theory, there are various machines that you're going to learn. So we are going to start with the very first machine, that is finite automata. Fine. It's also called as FSM. We'll come to know in detail what exactly is the difference between FSM and finite automata. To keep it simple, we can say that FSM is the basic model of automation, on top of which with few changes in the nomenclature or with few changes in the working principle, we can say that finite automata was built on top of FSM. So we'll discuss the problems based on FSM and finite automata in detail in the upcoming videos. Now, what exactly FSM is? FSM stands for finite state machines. Let me write it over here in crystal clear font, finite state machines. So finite state machine is nothing but a machine, as you saw earlier. It expects some sort of an input. It provides some sort of functioning or some sort of algorithm to that particular input, and you get some sort of an output, right? So finite state machines work on the same principle. You provide something called as I, that is input. You have the second tuple as O, that is output, and S stands for states. So in short, IOS. So what it means is you provide some sort of inputs to a machine. The machine will keep on jumping between multiple states depending upon the input, depending upon the logic. It will keep on changing or transitioning between multiple states, and at the end it will give you some output for that particular state and input combination. So I can say that a finite state machine basically consists of these three tuples. These are called tuples, T-U-P-L-E-S, tuples, you may call it as you wish. I can write it like this. The machine or the finite state machine is basically consisting of these three terms, that is I, O, and S. So this basically stands for input, O stands for your output, and S stands for state, right? So now how to define what is the input, what is the output, and what is the state? I'll just give you a brief introduction over here. I'll start with the problems in detail in the next video. So what exactly happens is you're just assuming that the machine is at its initial position. It is right now at its initial position, that is we are starting from a state called as QS state, which is nothing but the start state. You can call this as the start state. Now let's take an example. The machine can take inputs, binary inputs, for example. So the I over here will be a set of zeros and ones. Why? Because we are considering only binary inputs. So let me write it over here. This is nothing but binary number set. So we can say that the input is nothing but a set of binary numbers. Similarly, what is the O over here? Well, it depends upon what you actually want from your machine. For example, if I want to check whether this particular binary number is divisible by 2 or not. So this is my problem statement. So if I want to create a finite state machine to check whether the binary number is divisible by 2 or not. So what I will do is I will have only two options for outputs. Either it will be divisible by 2, so the output will be yes, or it will not be divisible by 2, so the second output will be no. So these are the two options. Either it is divisible by 2, that is yes, or it is not divisible by 2, that is no. Fine. Similarly, what are the intermediate states? S stands for states. This you have to decide. Now let me show you how we can decide upon what are the various states. Now, as you know, we are testing whether the given number is divisible by 2 or not. So what could be the states? If I divide a particular number, for example 11, if I divide this number by 2, what would be the possible remainders? The remainder would be either 0, that is the number might be completely divisible by 2, which in this case it is not satisfying the condition, because 11 by 2 remainder will be 1. Okay, so what are the possible values of the remainder? The remainder could be either 0 or 1. It cannot be 2, because if remainder is 2, it doesn't satisfy the condition, obviously, because if I am dividing a number by 2, the remainder cannot be 2. So at the max, the remainder can be either 0 or it can be 1. So these are nothing but the states, or this corresponds to the states. So I can say that 0 and 1 are nothing but the remainders, where this particular 0 corresponds to a state Q0 and this particular remainder 1 corresponds to a state Q1. So in short, we have 3 different states, where Qs is nothing but the start state or the initial state, Q0 is the state which corresponds to remainder 0, and Q1 is the state which corresponds to remainder 1. So in short, we have 3 different states which are reacting differently to various inputs, right? So with this, congratulate yourself, because you have created your very first machine in this journey of theory of computation. So as you can see, this was a very simple process. It's not a difficult subject to learn. You only need to follow certain instructions. You only need to follow what exactly is being asked in the problem and just follow along the videos over here. You will definitely get a hang of it, how to solve problems, how to create your own machines based on different logic. So let me just repeat what exactly we have done in this problem so far. You were asked, or you were given a problem statement to solve a particular problem where the machine needs to accept a particular string, binary string or binary input, if it is divisible by 2. On the other hand, if the number is not divisible by 2, it should reject the string, or in short, it should give an output that no, the string is not accepted. So we had 3 tuples, or we could say 3 tuples. Over here, the 3 tuples are I, that is input, which are nothing but 0 and 1 in this case, because we are dealing with binary numbers. Similarly, the second tuple O stands for the output. Over here, the output is nothing but either yes or no. That is either divisible or not divisible by 2. Similarly, the states are nothing but, we have just now seen, QS stands for the initial state. The initial state is nothing but a state where you are actually preparing your machine to start taking inputs. It doesn't have any inputs as such. It will take the inputs from this particular state. Later on, you will see in the upcoming videos that QS and Q0 ideally could be combined together or merged together. We'll see about those problems. We'll learn about those problems in the later sections. But at this point of time, just keep in mind that QS is nothing but the initial state from where your machine starts executing or taking inputs. Q0 is the state over here where we are taking the remainder, or where we have the remainder as 0. Similarly, Q1 is the state where the remainder is 1. So on that note, we complete our very first problem on finite state machines, and I hope you like this particular video. So if you like the video, do share it with your friends, do subscribe to the channel, and stay tuned for the upcoming videos, because it's just the tip of the iceberg. I have planned around 70 to 80 videos in this particular course on theory of computation. It's going to be a detailed course, you can say a master class on theory of computation. So stay tuned. God bless you. Take care. Keep learning.